Okay, so in today's lesson we're going to be talking about something called direct variation. And we talked about this in another form in 7th grade, so it should be vaguely familiar to you. We're going to talk about direct variation and constant variation, identify whether equations represent direct variation, write equations, graph equations, and write equations from a table. It's basically like all what you've done before, except that in direct variation, it's a linear equation whose start is 0. So it's a line that goes through the origin. You might remember from 7th grade we had graphs of, we had to decide if a graph represented a proportional relationship, and one of the things, if it represented a proportional relationship, it had to be a straight line and it had to go through the origin. So proportional relationships are all direct variation. It's just another word for that. I kind of wish that in your 7th grade book it would just call it the same thing and then we would be all good, but it doesn't. So just so you know that it is the same thing. So a direct variation is a linear relationship. So like all linear relationships, it has a constant rate, and that is its slope. And a line that represents direct variation always passes through the origin. A direct variation is represented by the equation y equals kx, where k is the constant of variation. And k is also the slope of the line. So remember when we wrote linear equations from tables in chapter 4, we used the formula y equals the change times x plus start. Direct variation is just this part. Y equals the change times x, because the start is always 0. So there's a plus 0 there that we don't need to write. So k in this equation just represents the change or the slope. And so it would be nice if in equations of direct variation, if they just used m. If I were writing the textbook, I would just say y equals mx. And then we'd be good, because the next equation we're going to learn is called slope-intercept form, and that's y equals mx plus b. And then actually in your 7th grade textbook, they used the letter c to represent it, but it's all the same thing. This k in this case represents the same thing that m represents, which is the slope or the change. Okay, so let's look at how we know whether an equation represents a direct variation. To identify a direct variation equation, first you have to solve for y if it's not already solved for y, and then you see if it's in this form, if it's y equals something times x. So let's take a look at some examples of this. This one says 7y equals 2x. In order to know if that's direct variation, it's not maybe immediately apparent, we need to solve for y and get y by itself. So this is like what we did at the end of, I believe it was the 2nd or 3rd unit, where we did the equations where we solved for a variable. Do you remember doing that? That was hard, I remember. But it's not so hard when you're just solving for y. So we need to get y by itself. How would we get rid of the 7 in front of the y? Gretchen? Let's divide. So we're going to divide by 7. We end up with y equals, I'm going to write it as 2/7 x. So that does represent a direct variation, because we have y equals something times x. And this something is the slope or the change, which in this case we call k. So k equals, wait, I wrote 3, but I meant to write a 2. K equals 2/7. So this is the equation, and then this I'm just telling you what k is. Okay, let's try another example. So this one is a little more complicated because we have more to get rid of. What would I do first if I wanted to solve this second equation for y? Colin?
Subtract 4x.
Good. I need to get rid of the 4x, so I'm going to subtract 4x from both sides. Now on the right side, there's nothing to subtract 4x from because there are no 4x's. So I'm just going to write 3y equals 8 minus 4x. Now what would I do to get y by itself? Sophia? Divide by 3. So I end up with y equals 8 minus 4x over 3. If I wanted to, I could separate this out and write 8/3 minus 4/3 x. Does that look like it's direct variation? No, it's not direct variation because of this. We have a change times x plus a start, which is not 0. So this line, if we graphed it, would not go through the origin, so it would not be direct variation. Okay, next example is one for you to try, so we're just going to take a brief minute for you to try that one. Okay, volunteer to tell me how you solve this. Athena.
You subtract 4x from both sides to get 5y equals negative 4x.
Good.
And then you divide both sides by 5 and get 5 equals,
You mean y equals?
yeah, y equals
Y equals.
negative 4 over 5x.
Good. So is that direct variation?
Yeah.
And what would the constant of variation be? Okay.
Negative 4/5.
Negative 4/5. So k is negative 4/5. This is the proper equation. K equals negative 4/5. Any questions about that?
This one, so
Yes.
you would have to have the 0 minus 4.
No, you don't have
Okay.
to keep the 0 there. The 0 has to be there in the original equation because you can't just have nothing there.
Okay, because I wasn't sure if you wanted it like where the y was.
Yeah. Emma.
Okay.
So why didn't we switch the neutral like we did for the example and made it 3y equals 8 minus 4x? Why didn't we do that one?
Well, we kind of did. We would have had 0 minus 4x, but we didn't need to write the 0.
Okay.
Good question. Any other questions? Good question? No? Okay.
So you don't actually divide
You don't divide at first. First, you're subtracting the 4x.
where it's before to divide. You're not actually going to divide that.
No, it's better to leave it as a fraction. Okay, now we're going to talk about writing a direct variation equation. These ones are a little more confusing. First, we have to find what the constant is, then we have to write the general equation. I want to look with you at the original equation, y equals kx. So if we have 2 points and we want to find k, I'm now going to solve this equation for k to kind of give me a shortcut way to find out what k is if I need to find k. If I were to solve this for k, I need to get rid of the x. So what do I do to get rid of the x that's beside the k? Athena?
Divide x from both sides.
I would divide x. So now I have y divided by x equals k. Okay, this is going to be important, so make sure you write this down. You can figure it out on your own. You don't need to have this equation memorized, but it's helpful just to know k is always y over x. And that goes with what we learned yesterday about slope. Slope is the rise over the run, right? Which is the change in y, how much y changes, over the change in x. And k is the same thing. It's just the change in y over the change in x. We don't need two y's because one of our points is always going to be 0, 0. So we don't have to subtract anything. Okay, so our example says, suppose y varies directly with x. So this is important that it tells us that it varies directly. This is telling us, okay, it goes through the origin. This is direct variation. I can use this formula. And y equals 35 when x equals 5. What direct variation equation relates x and y? So first we have to answer this question. And then what is the value of y when x equals 9? Okay, so first we have to find what k is. We know that y is 35 when x equals 5. So to find k, we're just going to take this 35 and divide by 5. So k equals 35 divided by 5, which is 7. So we know that k is 7. So our equation is just y equals 7x. We just have to multiply x by 7 to get y. So that answers question number 1. Any questions about what I did right there? Okay. Second thing, what is the value of y when x equals 9? How would we find that? Rosa?
Multiply 7 by 5.
Good. We have to multiply 7 times 9. We have to put the 9 in for x. So number 2, we just say y equals 7 times 9, which equals 63. So we know that y equals 63 when x equals 9. Okay, I want you guys to try the next one. I'll give you a minute to do that. Okay, first volunteer to tell me how do we find k? Sophia.
You have to divide y.
Good. K equals y divided by x. So y is what in this case? 10. And x is, so 10 divided by -2 is -5. So we know that k is -5. Another volunteer to tell me how I would put that in an equation for direct variation. What's my equation going to say? Same?
Y equals -5x.
Good. Just y equals -5x. So what we're finding, when we're finding k, we're finding the change. So this is just y equals the change times x, just like we wrote linear equations before. Now it asks us, what is the value of y when x equals -15? Some of you were trying to take this -15 and were trying to divide by the -2. You were just, or divide by, you were trying to do 10 divided by -15. But these two go together. So on our graph, when x is -2, y is 10. But y is not 10 when x is -15. That's what we're trying to find out. So we're using the equation that we just wrote. We're using this equation, and we're substituting the -15 in. So we have y equals -5 times -15, which is positive 75. Okay, any questions about that? Okay, let's see. I think I'm going to stop here in the notes and have you practice a few of these. We're not going to go into any more graphing, but some of you are just a little bit fuzzy about this, and I want to make sure you're confident with this.